Hi, I'm Manas, and I'm Jihong from Cisco. Uh, we are going to talk about in-sonic in-service software upgrade. No, in-service sonic upgrade. Uh, I think this ISSU term has been around for more than 2 decades. It's nothing new, uh, but it's still so important. Uh, I think over the last few presentations, we have seen uh, there are new and new features being adopted in Sonic as the adoption of Sonic is increasing in from hyperscalers is going to large enterprises and other. So upgrade still remains very important for Sonic. Now, the very reason ISSU existed in traditional losses, in a nutshell, Sonic needs it for the same reason. So, but what ISSU is giving you here is an upgrade with data plane changes and keep sub-second downtime in terms of traffic, data traffic in data plane. And this is something, if you look back 15 years back, there was an RFC, I forgot the number. There was an RFC on ISSU which was developed, and it talked about this, keeping the data plane loss less than second. So here we are going to talk about same thing, how we are going to do this in Sonic. And we will take the experiences, what we have gone through in traditional NOSes, and not make those mistakes in Sonic and go forward with something in ISSU. So these three things are common. We all know it avoids the network churns. If you keep it below, why that sub-second thing, right? Why we want it sub-second? I think most of the cloud-based applications, if you try to keep the data traffic disruptions below a second, then the application's user experience is seamless. So that was important of keeping that sub-second loss of data plane. To that, why sub-second, why data plane changes? As I said, I don't think we are at a stage where new features are all done in the P4 pipeline. Still features are coming in, and P4 pipelines are still evolving, changing. We are making changes there. So data plane changes are unavoidable at this point. So Sonic is not that mature. Yeah, we are not going to make any P4 changes. More of the vendors are coming too. The other thing is that if you have bugs, updates can be rolled out with, and it will reduce the failure impact. Moving on, so how it fits into Sonic architecture. The traditional NOSes, we knew that storage of state was at multiple places spread around. With Sonic, that's the advantage. You've got a central database container and everything stays there. So an upgrade always involves storing something and restoring back something. States are being stored and then states are being restored after the reboot, right? So Redis is a perfect place where we store back the state and then restore it back from the database container. So that helps perfectly fit into the Sonic architecture. Here we talk about how it fits into the Sonic design principles. So if you look at in Sonic, right, to that, with the evolving nature of updates, and Sonic already provides warm boot, fast boot. So the express boot is an extension to that, where it helps in upgrading the data plane too. So if you took a look at the current Arc agent code and the network applications, how they work, the warm boot is pretty much there. That is still needed for express boot. So you need that. So it will still need to store some state from the Arc agent into the persistent storage and then get it back and populate and then reconcile it when the config comes back after the reboot. So that's still happening. For example, we were doing this express boot for a feature in fine-grained desktop. So we want to make sure the flows were taking a particular path after the upgrade continues to take the same path. So which means that the hash buckets needs to be restored back in the same way and programmed back same into the ASIC so that the path stays the same. So that's one example. It comes to syncd. For warm boot, you would see that we'll dump the ASIC DB and restore it and all that. But in case of express boot, we don't need to do that. So the restore the state, same as we would, that's the idea of ASIC. So how we do it, we'll go forward and see. I already spoke about that. The reconciliation is done at application level. We still need to keep doing. The SI API call changes, right? In warm boot case, it used to maintain two queues, right? SI ASIC state restored and intended. And this is kind of not more needed with the Express boot. There was already a talk on this, and they were calling the term as RSR or something. I like to stick to ISSU, which is there from a long time. So this picture in a nutshell shows like what's going on with the Express boot. If you see at time t0, I'm on the right side, yes. Time t0 pre-shutdown phase, we save all the state. For example, we have learned neighbors, we have learned some FDB entries, so we'll have to save that. And then at this point, the SONiC is also at v1, SDK is v1, and now we take an Express boot upgrade, and then at that point we basically restore all these things, and then we will basically push the device config, and all that stuff will be replayed. All these things goes into the new SDK v2. Now we're booted with this SONiC v2, SDK v2. Note at this point, we are still running the NPU with v1. And how do we do it? Control that in the syncd, we'll come to that. But until this point, until all the features are configured with the new SDK and with the new image, the NPU version still remains the same, which means it's running the same P4 program. After that is done, we do stop traffic, and then we flush all this config batch. Till this, there was a batching happening in the SDK, and then we batch DMA and program the NPU, all the registers and the tables that we have. And then we say, okay, start back to traffic, and then the new feature updates come, normal operation continues with the NPU v2. So that's the typical flow of what we are trying to do. Of course, there is a hidden traffic here, which is sub-second. Can we do without a hit? Yes, we can do without a hit, but it adds to a lot of complexity. That's the thing we have learned from. I think the ISSU existed for a long, long time in traditional network operating system. I don't think there were many takers of that because of the complexities. There was always a scary part, like if something will break because we're going to use, and because that's where we're trying to over-engineer probably. Like, okay, no losses, we'll do a lot of stuff to make that work, and then end up with bugs, and then the customers were not ready to take it up. I think in this place we have taken, okay, let's not do all those complicated stuff, and let's do it this way, and I think it will solve most of the use cases. So here we talk about like what all can change, right? Typically a SI attribute or an API can change. So in that case, SONiC v2 will program as usual with the new API and attribute. SDK v2 just caches during the T1 to T2 phase, and eventually we'll program with that when the new NPL comes in the T1 to T2 to T3 phase, it will just push those things via the syncd. A capability gets added, it's the same thing. So there is just like there is no reconciliation happening at the syncd layer or anything. You just have to push it. It just gets in, no complexity. But yeah, now again, who's going to do warm boot? There's a comparison, like when you want to do warm boot, when you want to do express boot. As I said, right, this is more for a planned upgrade, right? And if you are trying to do a planned upgrade, then express boot makes more sense because you know that you don't want to get any kind of data path loss. Whereas the warm boot was like when if you have some failure, right, and you know that the traffic is already down, right, you want to quickly come back with a new thing, right, then you probably go with a warm boot where anyway we have lost traffic. But let's say you have lost traffic on one particular node, and then you want to upgrade several other nodes, you probably can go with express boot with bare minimum losses to solve that bug. Now, when it comes to SONiC actions, in warm boot case, we were doing all these things. The only difference is that we don't do the syncd reconciliation in case of express boot. So it still leverages whatever is there in the current warm boot and fast boot architecture in SONiC. From SDK actions, it's kind of very similar, just that here we don't reset the same thing. We're not resetting anything. We don't touch the data plane. The only thing that happens here is that we store all these things in the host memory for a while, and then post stable configuration will stop the traffic, batch the program, send it back to the NPU over DMA. So the critical part here is that how we can minimize the time. Yeah, this is something which is vendor dependent. How is your architecture? Do you have a DMA engine through which you can push it as fast as possible, all this config? If you don't have, then you have to rely on the PIOs, which may take more time, which can increase your downtime. But this is like a very vendor dependent stuff. If you want to fasten it up, you need to have some sort of a DMA so that we can push these register writes and enable back the traffic. And then you reconnect to the NPU, and then that's what the Express boot works like. Here we talk about like what it achieved. It removes the restriction that we had. We can't update the data plane without more. So I think the previous ones were aimed at more than 30 seconds of losses in data plane. This one brings you down below 1 second for sure. Practically we have seen kind of less than 100 milliseconds losses with certain scale. Probably DC scale, we'll see something like that. It still leverages the warm boot infrastructure. All is there. We're going to reuse that. How it does that? There were some extensions made to the SI specification to indicate this kind of config done and all that. So all that is there is being reused by Express boot. That was probably added by the fast boot when it came. So it tells the SDK that, okay, this is a different kind of a boot, and you need to do, you need to save the config and then push back. So those indications are already there. And this is upstream in community. There is an HLD you can go over. Thank you. Questions?
Manas, there is used to be a feature called fast reset, which
Yeah,
used to do the same thing, right?
Yeah, I think it was never like this is same thing probably.
Yeah.
Because I think it was never upstreamed or something like that.
It's there. I think both are touching the same fast reboot script to do all these things.
Yes.
I think both are there in the same script.
This is Express boot script, which is based on that. So I don't know whether fast boot is there a script called fast reboot? I don't think so.
I think they didn't. Just okay. What I understand is the existing reset fast reboot script, right? That has this mode to do fast reset. Nothing new added. Okay. So for Express boot, you have created a new script, is it?
Yes.
Okay. And
that's right, Jihong. It's the same script, right? Yeah.
The same script, right?
Same script.
Then pretty much the same. Anything else to be changed?
Jihong, can you come here? You can answer from the audio can capture.
Yeah, this is the same fast reboot script. We just add a new reboot type called Express reboot.
Okay. And does it become vendor specific, or it can work for other vendors, or how is it?
Well, this is right now is we do have a check in the script. Basically check if this Cisco 6000 platform.
Okay.
Yeah.
Okay. So
if other platform want to use the same, they need to enable it. Yes, check accordingly, add their platform.
Okay. The other thing, I think one of the slides what it talked about is when you do a firmware upgrade, after the fast reset, you come up with the firmware upgrade. The new firmware could have more SI capabilities. So what is the hook for you to go and populate this capability? How do you advertise this capability to the NOS? I think one of the slides mentioned that.
Yeah. So the whole NOS is getting upgraded, right?
Okay.
So in this case, the entire SONiC image is getting upgraded, right?
Okay.
So if a new capability is being advertised, I think it's like this: the Arc agent code will look for capability, right? The idea is that, okay, if you have a new capability, Arc agent should actually query for that capability.
Okay.
If this capability is there, then use it.
Okay. And is there a way that I just want to update just my SING-D? Just for example, I get a new version from the SDK with a new firmware upgrade, right? In that case, if I do that, how do you do that? If just let's say that I get a new SDK version, and I just want to bring up SING-D with a new latest version, right? How do you do?
You mean you don't even reboot the SONiC thing, or just up? This thing is you have to reboot,
Reboot
the whole thing and
the
bring
SONiC.
Okay.
Yeah, best bet will be to repackage another one
Okay.
with the new SDK, new
Okay.
image, and then just move.
Move on.
So we don't have this like in service for each container to do this warm reboot thing. We don't have that.
Thanks. Thank you.